Okay, let's try to look through this last section on square root functions. So square root functions, you might think, why are we talking about square root functions when we've been talking about quadratics all this time, all the squaring functions? Well, that is because the square root function is the inverse of the quadratic, and that's what we're going to be talking about and remembering today. So let's do a quick remember of inverses. This will come up on the final anyway, so it's a good use of our time. Remember, inverses undo a function. Remember, they undo the function. And one thing they do is right here, they switch the ordered pairs. There was all these different properties. And when they undo each other, I don't know if you remember this, but if you took f of f inverse of x and we did that composition, remember, it made that super funnel. Like one function did something and one function undid it. So then you just got whatever you plugged in. You could tell in the graph because they reflect over the line y equals x. The domain became the range, and the range became the domain because the x and y's switch. And we were able to find the equations. We could switch the x and y and solve for y. And that would be how you could find the equation. So they did a nice little example for you right here. We'll look at f of x here. F of x is 4x plus 1. So one way you could find the inverse of 4x plus 1, which is this orange graph actually, is taking some points on it and just switching them. So 0, 1 would become 1, 0. Negative 1, negative 3 would become negative 3, negative 1. Or you could know that this is the same thing as y equals 4x plus 1. And then you could switch the x and y. And now solve for y. So you'd subtract 1 from both sides. X minus 1 is 4y. Divide each side or all the pieces by 4, and you would get, they wrote it as x over 4, which is the same thing as 1/4 x minus 1/4 equals y. Y-intercept of negative 1/4, kind of hard to see there. The slope is 1/4. It's a little bit easier to use the points that were switched from its original. Now, we did talk about finding the inverses of lots of functions, and then there were some things that came up that told us that there was going to be some issues. And this one is not one of those. That's what we'll talk about in a second. But if we find the inverse of this, you just switch the x and y and solve for y. So it becomes x plus 4 equals 2y. Divide everybody by 2. X over 2 is the same thing as 1/2 x plus 2. That would be the inverse. So if you graphed this and you graphed that, they would reflect over the line y equals x. But if you remember, we said that everything, all graphs, and all functions have inverses. You can switch the x and y of any graph or any function, but not all inverses are functions. And there was only certain functions that did have inverses that were functions. And to remember that, first of all, how could you check if something is a function? Check if a function. There were a couple things you could do. You had to make sure that each x had one y. So we could check the x's. And if you had a graph, you could do what we call the vertical line test. Now, because an inverse switches the x and y to check if the inverse was a function, we could check the y's instead of the x's. Or you could do the horizontal line test. And it had to pass these. Each y had to have one x. So each x had one y, and each y had one x, and these had a special name. These were called one-to-one functions. So all lines are 1 to 1. Examples we just said, 2x minus 4, kind of looks like that. Oh, that's so bad. It passes the horizontal line test and the vertical line test. It's a 1-to-1 function. But what's going to happen when we talk about parabolas? Parabolas are not 1-to-1. So they do have an inverse. I can switch the x's and y's of these guys real easy and graph it. But the inverse is not going to be a function unless we do some special things to make sure that it's not breaking any rules. Okay, so all functions have inverses. They just might not be functions. So here is a graph of 2x squared minus 8. So which one of these would be the inverse? Well, how can you find the inverse? You switch the points. So you don't know exactly where this is, except I kind of do because of the equation here. This point is 0, -8. So if this is on the original, what has to be on the inverse is -8, 0. Which one of these has -8, 0? Not this one, this one. Okay, you can do it again here. This looks like maybe it's about 2, 0. So 0, 2 would have to be on the graph, and it is. Okay, so this is the inverse. Is this a function? No. So the things that we like to do to make the inverse a function is we're like, okay, let's look at this graph, 2x squared minus 8. We'd like to make it 1-to-1. How can you make a function 1-to-1 if it's not 1-to-1? You can say, hey, just look at half of it. Pretend this half isn't here. So we'll say, hey, we're going to talk about g of x, which is 2x squared minus 8, but we're only going to look at half of it where x is greater than or equal to 0. And when that's the case, then when I switch the ordered pairs, I'm only switching the ordered pairs for this half, which would be the top half, and then that guy is a function. So that's kind of what we're going to be looking at today. So you're going to find the inverse, and we're going to talk about domains because domain will be a little bit tricky. Okay, so a quadratic and its inverse. Don't forget that it reflects over the line y equals x. They have a y equals x line here, and they show how it reflects. Now, if you look at just the blue piece, it would just go to here. And if you just looked at the blue pieces, it would be 1-to-1. You also could look at just the orange pieces, really, but the truth is nobody ever really does that. We don't like to just look at the oranges because it's more negative and we just don't do it as much. But you could. It's not wrong. But when you look at the whole thing, its inverse is not a function. So you could look at the positive half, which we call the principal part, or you could look at the negative half, which we usually don't do, but you could, so that its inverse will be a function. So how do you find the inverse? Well, it doesn't say make it a function. So how would we find the inverse, period? This is just the inverse. We know that it's not going to be a function. How do I know it's not a function? Because this function is a parabola, which fails the horizontal line test. It's not 1-to-1. But I can still find the inverse, same way as before. Switch the x and y and solve for y. Well, how do you solve for y here? How do I get y by itself? Well, you square root both sides. But don't forget, when you square root both sides, you can't forget your plus or minus. So what we get is two functions. Y equals the square root of x and y equals the negative square root of x. But they are together. Both of these are the inverse of that. When you put them together, it's not a function. So the whole thing is not a function. So we're going to deal with what we call the principal piece to make it a function. So instead, what we would do is say, find the inverse of this if x is greater than or equal to 0. Then you can switch the x and y and solve for y. And usually where you say, don't forget your plus or minus, you wouldn't say, don't forget your plus or minus, because I'm only worried about the positive part. If I said this exact same thing, I said x is less than or equal to 0, then my inverse would be the negative part. But we usually, like I said, don't do that, but you could if you wanted to. All right, so let's practice a little bit. Here is that 2x squared minus 8. If x is greater than or equal to 0, what will the inverse be? So let's switch the x and y and solve for y. So I get x plus 8 is 2y squared. I actually don't know how they want us to write this. So let's divide both sides by 2. I wish that would have been 4. So what do you have? 1/2 x plus 4 equals y squared. Square root both sides, and usually I would say plus or minus, except they restricted my domain to make this 1-to-1. So because it's dealing with the positive part, so am I, and I think we're going to let you leave it like this nasty looking fraction, the square root of 1/2 x plus 4. I'm not going to make you simplify that at all, okay? What if it was the negative part of that? And you want the negative square root side of it, which is the negative square root of 1/2 x plus 4. So this one is the negative side, and this one is the positive side. So which one is which? This one is the top part, and this one will be the negative part. Let's find some values. Oh, sad I deleted my equations. Well, I might as well just do it because it was kind of messy anyway. X equals 2y squared minus 8. What did we say? X plus 8 is 2y squared. 1/2, I said x plus 4 is y squared. Okay, so this is the square root of 1/2 x plus 4, and this is the negative square root of 1/2 x plus 4. So what would Q be? Q is plugging -8 into D. If you plug -8 into D, you'll get negative square root. Half of -8 is -4. -4 plus 4 is 0, so that will be 0. And take a look. Excuse me. D of -8 on my graph, this is the D graph, is 0. How about R? R is from the F graph, the top one. Plug in 0 into there, and you'll get the square root of 4. The square root of 4 is 2, so that will be 2. On this graph, you can see when you plug in 0, it's 2. Because this graph goes with this, it's kind of confusing because you have to keep going back and forth. S, if you plug 10 into the F graph, half of 10 is 5. 5 plus 4 is 9. Square root of 9 is 3. If you plug 10 here, you can see that it goes up to 3. And plug in 10 to the negative one here. Half of 10 is 5. 5 plus 4 is 9. Square root of 9 is 3, but it's going to be -3. Okay, so I didn't really like how they had to flip-flop those graphs, but we made it fine. So what is the inverse of the function? Is that the exact same thing I did? Oh, now it's a 4 instead of 8. Find the inverse. Notice, be careful, they did not restrict. So since they did not restrict, the inverse is not a function. So we're going to get plus or minus. We can do that. X equals 2y squared minus 4 plus 4. X plus 4 is 2y squared. Divide everybody by 2. 1/2 x plus 2 is y squared. Square root both sides. Don't forget the plus or minus because they did not break things down for us. Plus or minus the square root of 1/2 x plus 2. Well, how do you find the inverse of this guy? Well, you switch the x and y and solve for y, but look what happens. X equals y squared plus 4y plus 4. How do I get y by itself? Well, you complete the square, right? You could have completed the square first, or you can complete the square now. What square is this closest to? It's closest to a y plus 2 square, which will put 4 in the corner, which is exactly what I have. Now I can get y by itself. There's no restriction, so I will need a plus or minus here. Square root both sides. Don't forget the plus or minus. So plus or minus the square root of x equals y plus 2. And I'll get y all by itself. And your two functions will be 2 plus or minus the square root of x, which means 2 plus the square root of x is one part of it. 2 minus square root of x is the other part of the entire inverse. So it takes two functions to make one inverse. Find the inverse of this guy. This time they did restrict, so I don't need to do the plus or minus. They want the x plus is greater than, negative 3. So this is going to be the right side of the graph, which is the principal part, which is the positive part. So you switch the x and y and solve for y. And once again, this is not how I want it. I'm going to go ahead and complete the square. So what square is this closest to? Well, it's closest to a y plus 3 squared. That would put 9 in the corner, but I don't have 9. I have 0, so I will subtract 9. I have to get y by itself. I'm not going to do the plus or minus thing because we are looking at only half of it. This will be a function. And the first thing I'm going to do is add 9. So I get x plus 9 is y plus 3 squared. Now we square root both sides. We usually say plus or minus, but I don't have to now because we cut it in half. We're only looking at the plus part, and that's y plus 3. And now get y all by itself. Subtract 3. You don't subtract numbers with roots, so negative 3 plus the square root of x plus 9 equals y, and that is the inverse, and it is a function because it's only looking at the positive part. Okay, so what is the inverse of this guy? They went to all the parts. They did not cut it in half, which is why there's a plus or minus there. So we need to switch the x and y. So it's x is y squared minus 18y, and we're going to put it in vertex form so we can solve it. X equals, what is this closest to? It's a y minus 9 squared, which should put 81 in the corner. So to get to 0, I'm going to have to subtract the 81. And now we're going to get y by itself. So it'll be x plus 81 is y minus 9 squared. Square root both sides. Don't try to square root that 81. That 81 is part of the x. You cannot simplify that. Is plus or minus y minus 9. I didn't mean to put that there. I meant to put the plus or minus over here. There's the y minus 9. Now add 9 to both sides, and I get 9 plus or minus the square root of x plus 81. So they want to know what all these letters are. Okay, well, what letter is in front of the x? It looks like just a 1. So b equals 1. C is going to equal the 81. And d is the number at the end, which we put ours at the beginning, so it'll be outside. It will be the 9. Okay, so what happens when you are talking about domain of square roots? There are risk factors. The mother function of a square root graph is just y equals square root of x, and you're going to be pleasantly surprised how we graph these. And that means x has to be greater than or equal to 0, which it is, because you can't have a negative under the square root if we want to graph it. We're only going to be looking at part of it. So what is under the square root, we will have to make positive or greater than or equal to 0. So let's talk about domain. What is the domain of this guy? Well, you can't have negative underneath there. So 3t minus 9 has to be greater than or equal to 0, and we just solve it. 3t has to be greater than or equal to 9. Divide both sides by 3, and t has to be greater than or equal to 3. So this would be the domain. What is the domain here? Well, the domain here would have to be L over G has to be greater than or equal to 0. But we have another risk factor here because G has to just be greater than 0 because G cannot be 0, because if G was 0, you would be dividing by 0, which is not okay. So they want to know what the domain would be here. Well, because G cannot be 0, there's no possible way. I guess if L could be 0, potentially. You just have to be really careful. L over G has to be greater than or equal to 0, but G cannot equal 0 either. So I think both parts of that would come in for the domain here. So L over G greater than or equal to 0, but G cannot be 0. And how do we graph? These are fun. Okay, so graphing, this is not in the official notes, but I want you to look at it. It is very much like parabolas, x minus h squared plus k. Numbers in front will be your stretch factor. And this is your grouping symbol. There are automatic grouping symbols with square roots. Your calculators know that. So this would go to the right h and up k. That's what this graph does with my square root graph. It goes to the right 2 and down 3. And that's where it starts. And it's going to go up like this because my stretch factor would be over 1, up 1, over 1, 3, 1, 5, and yada, yada, yada. How about this guy? Well, the starting point of your square root function would be at -1, 4. Stretch factor would be 1 this time, -1, so down 1 over 1, down 1 over 3, and so on, and it would be like that. So it's very much like quadratics. This one would just be to the left 5. And because the 2 is there, it'd be up 1 over 2 instead of over 1 up. And then 2 times 3, which would be 6. And it would just be a little bit thinner. So you could graph them if you needed to. They're very much like quadratics. But really, just square roots are just the inverse of quadratics, so they have a lot in common.